Yeah, we look at another manner in which we can measure angles, and this is known as radian measure. Now, previously in trigonometry, or whenever you came across angles, you measured that in degrees. So, for example, 37 degrees, 0.718 degrees, and you've indicated that by this notation, the degree notation. Now, another way of measuring angles is what is known as radian measure, and it's particularly useful in circular motion. So let's just quickly go through a brief introduction. Where does it originate? Consider this circle with center, the vertex, and let's say that, of course, is the radius of that circle. Now, I can obtain an angle like that. Let's say that's angle theta. And at the end of that angle, I can draw another radius. But that angle will affect this particular length of the circumference of the circle. Okay, so let me get that right. That over there. It's going to affect that length. That is, I'm going to use the letter S for that length, which is known as the arc length of a circle. Of course, you get a circumference of the circle. A portion of the circumference is an arc. We know what an arc is. That's simply an arc, like that. Starting point and end point, whichever way you want to look at it. An arc. Now, this arc, of course, is not a straight line. We know that it's curved. But what is important here is that that arc length, this radius, directly affects that angle theta. In other words, the magnitude of that angle theta is going to depend on the arc length and on the radius. Now, just to see that, let's simply erase this. And consider another radius there. And in this case, the angle is now much bigger. That's angle theta. And now look at our arc length going right around. So that theta is affected by S, the arc length, and R. Now, not only is that angle affected by the arc length and the radius, but also the circle itself. A small circle, slightly bigger circle, we're going to get smaller radii, and angles and arc lengths. So in effect, we can say that the angle theta is actually dependent on the ratio of the arc length to the radius, and there we obtain a mathematical equation. Theta is equal to S over R. In other words, the angle theta is equal to an arc length divided by a radius. Now, if we consider a complete circle, so in a complete circle, if we have to go right around, the angle theta is how many degrees? 360 degrees. And if we go right around, the arc length is actually the circumference, which is equal to 2 pi r. Now take this information and substitute it into there. We then obtain 360 degrees is equal to S, the circumference 2 pi r, divided by r, and there we get our most important definition, that 360 degrees is equal to 2 pi, and we call this radian, a dimensionless quantity known as radians. Now that is extremely important. And just to make it a little easier, we're going to divide by 2 to obtain 180 degrees is equal to pi radians. Now, this particular concept is exceptionally important. All your trigonometry, all your angles, your geometry that you've come across before, you only use degrees. Now you're going to work in both degrees and radians. Degrees and radians. Just a quick aside, in case you do come across this, another definition that is used is that 1 radian, in other words, the angle that you see there, 1 radian, is an angle formed when the radius of circle is equal to its arc length. So when we have, and when we can find a circle in which, or a situation as I've indicated here, where the radius is equal to its arc length, then that will subtend an angle of 1 radian measure. Now that is the concept of radians. Simply, it is a dimensionless quantity. It is another way of measuring angles. Radians, degrees. From now on, whenever you come across trigonometry or angles, you're going to think, hang on, what is this in? Degrees or radians? Right, so how do we go about converting this? Well, the conversion is very straightforward. We already said there that 180 degrees is equal to pi radians. So how do I get 1 degree? Well, divide by 180 and I'll get 1 degree is equal to pi over 180. Now, here we have the conversion from degrees. Sorry, why did I do that? This is a conversion from degrees to radian measure. In other words, if I want to find out how many radians in let's say 90 degrees. I take the 90, multiply it by pi over 180, simplify, and that is half pi or pi over 2 radians. 180 degrees is pi. 90 degrees is pi over 2 radians. So that is your procedure when you are given degrees and you want to convert to radians. What about radians to degrees? Well, let's just do the other case. And now I'm simply going to transpose and say pi radians is equal to 180 degrees. Therefore, 1 radian is equal to 180 degrees divided by pi. So it's just the inverse. So for example, if I want to know, if I have, let's say, 3 pi over 2 radians, and I want to know how many degrees is that, then I take 3 pi over 2, I multiply it by 180 degrees over pi, simplify, simplify, 2 into 180, 90 times 3, 270 degrees. So that is your conversions. If you want to go from radians to degrees, multiply by 180 degrees over pi. If I want to go from degrees to radians, multiply from, so let me write it here. If I want to go from degrees to radians, multiply by the reciprocal, the inverse, pi over 180. So let's look at some special cases. Let's take, for example, right, let's go from 45 degrees. That's in degrees. I want to know how many radians. So all I have to do, therefore, 45, this is going from degrees to radians, multiply by pi over 180 degrees, simplify, and what do you get? Pi over 4 radians. 30 degrees, multiply 30 by pi over 180. Simplify, pi divided by 6 radians. Do I need to continue? 120 degrees. I want to find what's the corresponding radian measure. 120 times pi over 180. Repetition, repetition, repetition. Simplify, 2 pi over 3 radians. Okay, you get the picture? But what if it's not a special angle? 45 degrees. 54 degrees. You're still going to do the same. 54 times pi divided by 180. But now you will use your calculator, because that can't simplify to a very nice fraction. It may be a bit complicated. These special angles you need to know. In other words, you need to know 90 is pi over 2 radians, 45 is a quarter pi radians, 30 is pi over 6 radians, 54 degrees, what if I make it 54.2 degrees? How will you convert that? 54 times pi over 180. Take out your calculator, multiply 54 times pi, divide by 180. Correct to 2 decimal places. I get 0.94 radians. Now look very carefully. I stipulate here 0.94 radians, R. Over here, I can also write radians in terms of pi. So 2 pi over 3. I don't need to include pi. In fact, I can use my calculator and work that out, and I can get a decimal place. But when it's special angles, we tend to leave it as nice fractions. When it's not, we can convert to decimal places. 0.94. And I'm also going to make a very, very important point. Look here. It says degrees. There's the symbol for degrees. When you don't see anything, if you don't see anything, and you know you're dealing with angles, then it's taken to be radian measure. So if I give you 203.79 degrees, and I say, find the corresponding radian measure, then you're going to do this, 203.79 degrees multiplied by pi over 180, and you're going to get an answer of, let me take my calculator out, 203.79 times with pi, inverse pi, divide that by 180, I get an answer of 3.557. Then the other is also important. In other words, if I give you the reverse. So for example, if I say I'm dealing with a radian measure of 3/4 times pi, what is the corresponding degrees? Now we're going to go from radians to degrees. What will I multiply by? 180 over pi. Work that out. 3 times 180 divided by our 4, 135 degrees. You do another. What if I give you 5 pi over 6? So that's my radian measure. What would you multiply by? 180 divided by pi, and that gives me 150 degrees. So there's your conversions. We can go from degrees to radians, multiplied by pi 180 over pi, pi over 180, sorry. When we go from radians to degrees, 180 over pi. Just get that. You'll notice that when you go from degrees to radians, the angles, degrees will cancel off. Likewise for radians. Now, just one more thing before we go on to the next part. 1 degree is equal to pi over 180. And 1 radian is equal to 180 over pi. So how many degrees in effect? Well, use your calculator over here. 180 divided by pi, 180 divided by your pi, and there 57.29 degrees. So it's approximately 57 degrees. Now that gives you a very good idea, especially when you get to calculations. Am I getting an answer which seems to be correct? So 1 radian is approximately 57 degrees. Right, so extremely important here. Of course, converting from degrees to radians, radians to degrees, and we can look at anything. Now, what about other cases? For examples, if I give you 2.34 radians, how many degrees? you're going to take 2.34, go to your, what must I multiply? Radians to degrees, 180 over pi. So multiply that by 180 over pi, and I get an answer, 2.34, I get 134.1 degrees. Now, calculator. Take out your calculator. Yes, have it by your side. I want you to find the sine of 30 degrees. So you got your calculator now. Now, obviously, I got a different calculator to all of you. Some of you may have. I think I have a calculator which most of you could have, but anyway, depends on you. So we have sine of 30. You're going to enter sine 30, work that out. Oh, 0.5. You happy with that? Okay. So find the cosine of 258.3 degrees. Are you sleeping yet? Cosine 258.3 degrees. I get an answer of negative 0.20. Let's take it to 3 decimal places. 203. You can check that. Now I want you to find the tangent of 2.37. What is the tangent of 2.37? And your answer should be negative 0.973, correct to 2 decimal places. Oh, did you get that? Oh, am I wrong? Or did you actually get an answer 0.04138? Yes, yeah, I'm sure you're saying that, hey? That is wrong. Why? What was the one point I emphasized in the previous slides? You must be careful. Are you working in degrees or are you working in radians? That's degrees, that's degrees. What's this? You don't see any symbol indicating radian, a degree, sorry. Therefore, that is in radians. Now, follow this extremely carefully. So how do you go about getting the correct answer of these trigonometric functions when you are dealing with radians? Well, there you go. This is my Casio, okay? You're going to find out for your particular calculator how it works. So look on your calculator and look here. My calculator got a D there. That means I'm working in degrees. So when I identify that I am dealing with an angle in degrees, I must have my calculator in degree mode. So this is the mode that you need to look at. Either degrees, D, or radians, R. Now, Many calculators actually have D or G. The R is radians, the D is degrees. The G, we're not going to work. It's actually known as gradients, but we won't use that. So how do I get my calculator in the correct mode? By default, it is in degrees. If I get, let's just go back. If I get the sine of, let's say, 3.92, then I know that is in radian measure, because that is not, I do not have the symbol for degrees in it. So I cannot use the calculator when I see D. So how do I go about changing it? Well, for this particular calculator, you press Shift and Setup, and it will show you the screen here. Then you can see, you then enter 3 for degrees or 4 for radians. Now, if you have a calculator right now, and this is it, do it right now. Press Shift, Setup, press the number 4, and then this will then change to a R, meaning your calculator is now in radian mode. Now, for all your other guys that have these fancy calculators, find out how to use it and get to do it correctly. So let's just go back. Now, I have sine 0.392. Is your calculator in radian mode? Okay. Work it out, sine of 3.92, and I get an answer incorrectly. I did not change. I need my radian measure, so that's sine 3.92 gives me an answer of negative 0.702. Did you get that? Guys, I cannot overemphasize this particular lecture. If you simply ignore what we have done right now and you do not follow the point that I've made, have a look at this example. Let's say you have to calculate sine of 59.3 degrees, multiply by the tangent of 1.7, divide that by the square root of the cosine of 2.3. This is not a straightforward question. Why? Because this is an angle which is in degrees. This is an angle which is in radians. This is an angle which is in radians. So you cannot do it all at once. Yes, if you have something that's nice and you came across something like this, cosine of 23.3 degrees, 5.7 cosine 23.3 times, let's say, the sine of 45.9 degrees, 0.9 degrees. Oh, you worked that out quite easily. But your calculator was always in degree mode. Now you're going to have to think carefully. You're going to have to look at the question and decide, is this calculator in, is this question or that particular part of the problem. Is it degrees or radians? So you'll actually have to do the separate. Work that out, sine of 59.3. So you're going to go to your calculator and you're going to say, oh, that's degrees. So I'll have to change it to my correct mode, put it into degrees, and I'll find sine of 59.3 degrees. And I'm going to get an answer. I'm going to write this answer here, 0.85985. Then I'm going to go to tangent, 1.7. But that's in radian. So I'll have to go to the calculator, change the mode, go to radian measure, and now work out tangent 1.7. Get an answer. I get negative 7.69660239. And do likewise for this one. And then after I have that multiplied by this, divide by that, that will give me my final answer. So guys, I emphasize this. Must emphasize that this video lecture extremely important, very important for you to identify when you're in radian measure or degrees. We'll stop there.